Ladies and gentlemen, good afternoon. It's time for our station 6 now. Last station today. We have the last information to share of us. Today's the session's main topic is the safety. I think nowadays the refineries and the petroleum industries are the industry we cannot live without it. But however, the chemical process and equipment are most complicated than others, and sometimes they have accidents occur seriously. So there's a lot of people. They are concerned about the environment and the climate change, and there are some people around the plant that don't like the plant to build a new plant around them. So how do we ensure the effort on the safety and the environment to protect them, reliable performance to them, and make the graduates become essential sustainability factor? I think everyone they have the duty to make our next generations continue to live. But how do we to make achieve to successful? That's we want to talk today. The first one, our speaker, he is from the Singapore. And the title of the topic is Congruence on the Process Safety Performance Indicator, PSPI. Mr. Bernard Leong is the HSE manager of the Petrochemical Corporations of Singapore. He currently chairs of the Regulatory Affairs Committee of the Singapore Chemical Industry Council, SCIC. He is also a registered professional chemical engineer with the Singapore's Board of the Professional Engineer and have over 33 years of the experience in the process industry. So let's Mr. Leong to talk about his speech.
Okay, good afternoon and good evening. I think for those in New Zealand, it's past the dinner time. Yeah, so it's afternoon in Singapore currently. So I'm glad, I'm honored to be invited to speak at this conference. I think the last one we had was 3 years ago, 2019, in Korea. I had the opportunity to meet many of you in Korea. And I hope that the next one, we can see each other in person. So today I will be sharing on the PSPI, it's performance indicators for process safety as part of the process management PSM system. So just a quick intro of my company. We have 2 ethylene crackers in Singapore, and it's almost 40 over years ago that we started this company, 1977. And that was when the company was first set up with the plant on stream in 1984. And at that time, PCS is the first cracker, ethylene cracker in Southeast Asia. And with the second unit in 1997. Currently, the shareholders is Japan Singapore Petrochemical Company Limited, which is led by Sumitomo Chemical of Japan, and PSPI and Xiao. This is a joint venture of Qatar Petroleum and Shell Petrochemicals. So it is 50-50. So here you see a map of Singapore at the tip or the end of the Southeast Asia. Above that is Malaysia. This is Malaysia, and yeah, this is Singapore here, right? And if you blow it out a bit more, this is grade 1 is actually the offshore islands, and the government actually reclaim all the sea, all the orange colors are reclaimed land. In other words, it is fill up the sea to join this whole 7 islands into what we call a Jurong Island. So PCS is here. Before 2000, year 2000, we can only go to the workplace by boat. And after that, there is a road link after the reclamation to the main island of Singapore. So for today's presentation, over the next about 20 minutes or so, I will share with you about my company's efforts and what we use as safety indicators, and also the challenges that we face, how we are able to sustain, to improve safety, how we regularly also review and analyze to further improve the means, or rather the extent to which we can able to measure performance. Among the key basic requirement is for this program to be accepted, to be embraced by the senior management. That is the key thing. In other words, it has to be top down, and we report the indicators to management monthly and to the board of directors twice a year. So what we're going to seek here is to have open discussion. It is something which companies currently they may or may not have such a PSPI, and many times we see that many companies sort of keep it close. In other words, there is no open discussion on the selection and also the trends in industry. So again, I also would like to get support from the respective countries' chemical associations, to also some kind of a benchmark and some platform to share such indices or such indicators. And I'm glad if the opportunity again, perhaps 2 years later, I can also share a continuation of what has the effort has gone in after today. So indicators, common indicators, they are used widely, not just in the process industry, also in the business, economic, even for the country. GDP is a form of an indicator. So to measure, economic, business, even operation performance. And process indicators, it is mostly restricted to the process industry, and it is custom with generally mostly site-specific indicators to monitor the performance of key risk control measures. So the purpose, just like all indicators, is to provide assurances that your barriers towards incidents, the control measures are functioning, are good and functioning, and that this is actually the basis for most safety performance systems, which is, I'm sure familiar with this Swiss cheese model. We do not want all the holes to align to prevent any incident. So how do we do that? Is that these indicators, each one of this layer, may be an indicator. So each one of these could be an indicator to tell you whether you're in the right direction, whether you should move the layer in or out, so as not to have it aligned to have a hole or any incident to happen. Now, the first step is actually to establish the program, the scope, and this info involves identifying the safety critical activities, and to also identify the measures in place for critical aspects, is to establish priorities and what you want to achieve, set outcomes, and from that you need to have a system to gather, to collect, to analyze data, and from this analysis, how to have a format which is easily digestible, easy to digest for general reporting to the management or even to the peers. So after having established the program, implement the program, that's not the end. You just need to monitor performance and with a regular review whether indicators are suitable, and indicators are giving the right direction, giving the right warning, or giving the right sort of activities that you need to take care of. And this is form a part of continuous improvement, something like a PDCA cycle kind of process. This again, from what we have gathered over about coming to 20 years of having this PSPI, it's of course a well-designed PSPIs can provide information on how well the risks are being controlled, whether there's any deterioration in measures, and it is a good indicator to provide early warning of impending issues or problems, or even to amplify the weak signals of major incident. So it's like we track near misses. Too many, you may lead towards a major incident. So these are things that we look at to give us early warning or to uncover certain weakness in certain systems. With this also, we have two sets of indicators. One is what we call leading. Leading means that it provides some kind of early warning or something like a signal for you to act on. These are things that you can take into account, how to streamline, how to improve on your systems. Next one is lagging. Lagging is something like a record of what has happened in the past, like the number of incidents, number of accidents. These are lagging. So when you track such indicators, if the lagging comes down, means that you're in the right direction. But leading goes up, you're in the wrong direction. So it's a balance between having a leading and lagging indicators. Now, one important thing also is that PSPIs should also identify degradation in performance. Over time, you can see, analyze the trend, to pick up any degradation, any deterioration. And of course, the thing is not to have, if there's all the way zero or there's no change, it's not good, because it shows that things are not improving, neither are they getting better. So also beware of this so-called some sort of flat line. It's like in medical terms, you're dead kind of thing. So it's good to challenge yourself to have some meaningful ways of analyzing, of reading, interpreting the indicators. Of course, one also benefit is having all this is actually to provide focus and justification for allocation of resources, financial or money, to improve the safety systems. Now, I mentioned earlier, the first step is to have risk profiling about what's your flavor and your taste, how much you are able to accept the level of risk, and what is the consequences. Okay. Again, this also leads generally to, if you have many sites, then it has to be aligned throughout all the sites, as well as to also analyze the vulnerability. Now, having put in place a certain countermeasure, this measure needs to be challenged or need to be tested for any vulnerability to make sure that they are functioning as required. And also, as I mentioned earlier, to have a balance of leading and lagging, because this together works in harmony, hand in hand, to provide you some real indicator of what's happening to your whole PSM system. Something number not too many, because too many you will lose track, to lose focus. So not too many, like 10 or so would be a good number. Too many, and then you lose focus, you lose track of everything. Too little, it may not cover what you want. So not too many, not too little as well. Now, indicators also, you need to set some critical ones for those that you really need to take care of, things like your change, any deferred maintenance programs. These are things that you have to have indicator, because these are critical must-do activities. So you pin an indicator to them so that it tells you, are you in the right direction? Are you doing things that you must do? There are many guidance out there. I think among them would be from the CCPS, API, UK. So there are many guidance out there. Even Singapore also has published guidance on PSPI. Some other things that, of course, it must be measurable. You cannot analyze what you can't measure. It must be actionable. In other words, if there's something that shows up, you must be able to act on it. Right? And of course, it must be reviewed regularly, right? Based on experience, based on industry, or based on any new inputs or new hazards or new risks. So with these indicators, you are able to actually set your directions, for improvement. Key thing here also is that it must be defined and not being able to manipulate. In other words, stay away from manipulation, because manipulation means that you're actually like covering up, you're hiding some things. The indicator must be robust enough to prevent or to minimize manipulation. And of course, one thing is that must have someone who is in charge, someone responsible for each and every item or indicator. Otherwise, look at me, I look at you, no one is in charge, no one knows what's happening. So a party or someone must be in charge, responsible for these indicators. Let me speed up it because I think I look at the time, it's less than 5 minutes to go. So the choice of indicator, it could be per subset. Per subset, small ones could lead to a bigger thing. So per subset can be a lean indicator, which is good. It tells you something like early warning or advanced warning of potential failure. It also tells you, trends that you need to follow up. Like if you have too many backlog in maintenance issues, too many backlog in maintenance work requests, that's also a problem that need to put more resources into maintenance. I mentioned earlier, beware of the flat line, because it is a zero or it's no change. You can't improve what you can't measure. You don't see the change. You don't know what's going on, so you cannot improve it. Okay, a bit more, just a history of what we are doing. 2007 is when we first, started this program. And as I said earlier, you need to have someone in charge, a working group, external party, right? And of course, there must be a review, right? Regular review. In this case, we do it annual review of the indicators. So for my company, we have one on a policy and also guidelines for product safety. So these two are the guiding documents, principles for our PSM, facility management, and also which also helps us to define our indicators. This, when we first started in 2007, we only had 6 indicators, right? I think all this will be shared with you later. So let me just quickly run through them. So we have 6 indicators for a start. And 2008, we added in 2 more. And you can see the first few ones are lagging, right? Number of incidents, number of loss containments. Later ones are more of leading, things like failure due to corrosion, failure of instrument, number of alarm activations, number of interrupt sequence. So these are all early warnings or early signs that you're operating the plant either too close to the design or nearing a sort of danger zone. So it gives you a feel of where you are and how to operate the plant. So in 2016, we had up to 12, right? And the guidance of CPS at the time. So we added in a few more, and we reference also to CPS as well. So one of the key ones we added is that the number of maintenance work items that were not closed for current year. This is those priority, or A and B means that it's a top priority. So if you have a lot of maintenance items that are being deferred or being delayed or being not worked on, it may affect your plant integrity, plant reliability, and in turn, it can result in failure or even explosion or fire. So it's also good to also monitor the number of maintenance work which have been raised, not completed. Currently, we have 13 here. This is our most recent indicators. Yeah, we have 6 lagging and 7 leading. So the top ones is lagging, and 7 to 13 are leading. Right? Yeah. So as you can see, when we have this program in place, 2007, we monitor the number of incidents, the frequency over the year, and we see in the first few years there's a good reduction in number of incidents. So shows that we are focused, targeted programs to arrest any processing incidents. And here is just a 1-year snapshot of the frequencies. So this, I put on these numbers. These are generic. So able to disclose without touching on sensitivity. So I put these numbers, these are the numbers, so you can see improvement that we have by having such indicators, so that we can tailor our programs, our focus, our target to arrest any increase or any potential persistent incidents. So it's a downtrend, right? And having this program, it also elicits, creates awareness of people on incidents and the consequences. So it sort of make people talk about incidents, about the consequences, and also about people who are also not familiar. They also can act as a third eye. Our contractors, they can say a third eye, to notice, because they are those who are mostly out in the field, so to report incidents. And also it makes people sort of more risk averse. In a way, you can say that try to escalate or bring up any small events, which as a whole helps also us to also monitor and improve on the processes. So what we learn is that, of course, acceptance culture is critical. Success, involvement of the workforce, with the responsibility, and of course, you need leadership, management, commit. Civic culture, I can sum in one word, is that it is how people behave when no one is watching. I mean, that defines a good civic culture. In other words, regardless of whether you have someone breathing on your neck or someone looking over you, you will still always practice safe work. So again, to maintain, it is a challenge, and of course, need to keep some indicators, and with your review, you can always drop off those poor indicators, okay? And we also include recently about human error, because we realize that as a aging workforce, new workforce, human error tends to play a very major role in accident. So what do I want, or what do we want out of this sharing? It is to elicit feedback, even discussion, whether are we doing right things, and how do we compare with others? What are others doing, and what are the variations? Okay? So my wish list is to have chemical associations collect, benchmark, publish such information. And of course, to encourage openness in the industry for companies to share the indicators and also some trends. Okay? So what we must do is that I just like to share about this story of black and white swans. I think most people know swans are generally mostly white. It wasn't until some years ago where people saw a black swan. So a black swan means that it is something which is not normal, out of the ordinary, which is not normally thought of. So same thing like process incidents, we want to eliminate those black swans in first instance, things that we have not encountered, things that people haven't not talked about. So these are incidents that can happen anytime, and anytime the swan can turn black, it becomes a big incident. And we need to always put in effort to make sure that the swan always remains white. Okay, with that, I thank you very much. Thank you for listening. Back to you. Thank you.
I would like to thank Mr. Bernard. He has shared with us the management at his company, PCS, and then he explained to us PSPI. And from the perspective of risk management, he explains some of the activities that were carried out and some of the control measures that were formulated. In turn, these control measures will become the foundation of PSPI, and then we can do PDCA, the individual task. By doing so, a company can continue to move forward and to progress. So I would like to thank Mr. Bernard Leong. Next, I would like to introduce our next speaker. He is Dr. Chun-Chi. He's a mechanical engineering. He's going to talk to us about the
at the Refinery Research Institute of CPC Corporation of Taiwan. He is good at the material selections and accident investigation and corrections and anti-corrosion risk assessment and non-destructive testing. He has the more 30 years experience in the material science.
Let us now welcome Dr. Su. Thank you. Thank you very much. Thank you, Mr. Huang. Distinguished guests, ladies and gentlemen, good afternoon. I'm very honored to be able to be here to talk about the use of RAGAGEP for MI implementation. First, I'd like to talk about two incidents. First, I would like to talk about the MI in PSM. And next, I would like to talk about the use of RAGAGEP in MI and case studies. I will use case studies to demonstrate my points. Process safety management. The goal is to prevent or reduce the poisoning, fire and explosion and other hazards caused by the leakage of toxic or other substances. We know that when there is an explosion or there is a fire, there's always a very huge loss. I would like to give you to show you some examples. First, I'd like to start with a poisoning event. This happened on December 3, 1984. This happened in Bhopal, India. There's a leakage of methyl isocyanate, and it led to 15,000 deaths and subsequently up to 25,000 deaths. Another incident is the leakage of chemicals, a rupture of a pipe in Hamburg. It also led to 300 million US in loss. Another example is here. This is in California. It also led to more than 1 million in losses. And here, this is a hydrogen that led to a corrosion. This happened in 2005. The company that was affected was BP Texas Oil Refinery because of a broke at the hydrogen piping elbow. It led to a loss of around 30 million US dollars. Another example was also in 2005. It led to explosion and fire. After 5 years, in 2010, in Tesoro Refinery, there's also a high temperature leads to explosion of piping, and as a result, it led to the death of 6 personnel. We talk about hydrogen sulfide. It actually H2S, so it has a very huge damage. It will also lead to a rupture of tanks. In the 1984 in Chicago, Action. There was a rupture of the tank, which led to 17 deaths. In addition, in 2013, there's also a hydrogen leakage from a pipeline, which led to explosion and led to fires. I have mentioned so many examples. All of these are caused by pipelines. We know that process pipers, there are 30% of the accidents are actually from process piping, and one of the causes is a mechanical failure or mechanical damage. And this is the main theme of what I'm going to talk about, and this will account for 40%. Because of the high number of incidents from broken pipelines, and because of insufficient expertise, many times people don't know which of the pipelines to inspect and what to look for. Are they going to look for rupture? Are they going to look for cracks? Or what are they actually looking for? Therefore, in the past, they normally use a device to check for leakage. However, this is normally insufficient because of different kind of leakage. There needs to be different technology to be used. Today, I'm going to talk about mechanical integrity. This is MI. What is mechanical integrity? Basically, it is it actually this concept actually replaces the our past understanding where we only fix something when it's broken. However, we need to take preventive measures in terms of mechanical integrity. There are 6 requirements of mechanical requirement. We'll look at number 4, which is inspection and testing. In OSHA in the U.S., it says that inspections should be performed on process equipments. This is our main theme today, which is RAGAGEPs, which stands for the recognized and generally accepted good engineering practice. There needs to be good engineering practices, and we should also follow manufacturers' recommendations. We can use of RAGAGEP in order to solve some of our safety issues. So what is RAGAGEP? They are actually a set of guidance documents. They are actually codes and standards that are formulated abroad. There are 3 types of guidelines. First, government regulations. Second, manufacturing and process licensor program. And number 3, industry standards. In the absence of all of this, of course, a company can also base their practice on operating experience and policy, and also those of insurance company. So these are some of the basis of RAGAGEP. If we look at process piping, we start from design, manufacture, and installation. We know that process piping are all manufactured according to Section 5, and during welding, it's based on Section 9. And during the operations, we need to know whether there are risks for our pipelines. We often talk about RBI, risk-based inspections. So we base this on our API 570. We can also use API 580. In Taiwan, the government hasn't specified how do we inspect piping. Therefore, we use what is commonly used internationally, which is API 5Z0. After our inspections, we want to know whether in the events of small defects, can we continue to use the pipelines, or do we have to replace them? We look at API 570. Therefore, we see that from the manufacture, from the installation, from operations, there are actually very good engineering practices from which we can take reference. API 570 is actually the code for pipeline inspection in the U.S. It has very clear specifications on how to inspect, what are the damage mechanisms should we look for, and what are, it's just like a person, whether our diet or our lifestyle will lead to what kind of disease. There are specific tests for these different kinds of diseases. Therefore, there's also different kinds of inspection procedures for different kinds of pipelines, potential defects. It also mentioned the frequency of these inspections, and then also the evaluation of data, which is based on 579. How do we carry out after inspection data analysis? All of these are clearly specified in API 579. In our company, we have experts who are actually responsible for this. Next, I have some examples to show how RAGAGEP is used in MI. We talk about API 570. It tells us the potential defects of the process piping. So let us look at examples. First is leakage accidents caused by non-compliance. This is non-compliance with API 5C0. Many times after the fact, we find that, oh, there is non-compliance with 570. This is one case. This is a pressure tubing. The diameter is 1/2 an inch. And it uses low pressure and high pressure to atomize the steam flow. And suddenly there's a break in the piping, and it led to a very huge fire. After inspection, it was determined that it was caused by a fatigue fracture. And the fatigue fracture occurred at the latch where there is a weld. If we look at ASME P31.3, we can see that this is a seal weld, and it's specified that the seal welding shall be done by a qualified welder. And if we look at 32.2.8, it says that the seal weld shall cover all of the exposed threads. However, upon inspection, it was found that not all threads were covered by seal welds. In other words, this welding was carried out not in accordance with good engineering practice. We have another example. This is the LPG process piping. Normally, the piping are washed with water. This is just what we see in the slide, which is on the upper right-hand side corner, right? So we have water washing tubing, and the first elbow then becomes very thin. And we look at API. 30 years ago, it already mentioned that there are some inlet, for instance, the water inlet from the first elbow to the second elbow is a very important point for inspection. However, this company forgot to check the elbows. So there was a rupture at the first elbow, and unfortunately, API was correct in saying that, we should look very carefully at the first elbow. In other words, if the company had known that API has required inspection of the elbow, maybe this accident can be prevented. Next, we talk about the contact point corrosion. According to API 570, it says that localized corrosion at pipe support contact point, it is a result of crevice corrosion due to deposits. In other words, it is less of a point and more of an area. Therefore, if not inspected, it will lead to leaks. In the past, if we look at the API text, there is no picture. So if we just look at the text, we don't know what is a contact point. We don't know what is a point or what is an area. However, if we have picture, like this example, then everything is very clear. This thing happened in 2001. The piping was directly placed on a concrete support, and the contact surface between the bottom of the piping and the support was corroded, and it was thinned, and it ruptured. Unfortunately, there was leakage of hydrogen and led to an explosion. This is the fourth example. Again, this is an API 570. It talks about dead legs corrosion. Some people may not be aware of what is a dead leg. It says that there needs to be a very clear inspections to look at the thickness of the dead legs. This is a high-pressure hydrogen tank. And the safety valve, which is stationary, and the dead legs refers to something that is stationary. There's no liquid flowing through it. So this factory actually inspected all pipelines and storage tanks. However, it didn't inspect this connector. Therefore, because of this defect, there was an explosion. This is also a failure to comply with API 570. In addition, we talk about we don't know which pipeline to expand. And then those are examples of not knowing what to inspect. Here is not knowing how to inspect. For instance, are we going to use a UT scan or profile RT? In this instance, if we make use of profile RT, we can very well identify the defect. If we look at the right-hand picture, we can see very clearly there is a thinning of the pipe. This is a global inspection. Another example. This is a separation tank, right, for a debuting tower. This is again, we use RT profile to inspect. If we look at the picture, lower left-hand corner, there is a severe thinning. This is very dangerous because we are looking at a LPG separation tank. So here we can just make use of RT scanning to see that, okay, there is thinning of the tank. There is a risk of leakage. API 570 actually laid out several guidelines. For instance, we talk about dead legs, we talk about injection points. These are unfortunately what API has covered. Next, I'd like to give you another case studies. First is the mixing points. Mixing points are locations in a process pipeline where two or more streams meet. API 560 actually has some statements on a mixing point. Mixing point is a point where streams meet. And at this point, there will be a very huge temperature variation, and it will thin at a faster rate, or it will lead to a faster mechanical damage. Because of difference in temperature, there will also lead to a thermal fatigue. And as a result, the process engineer, the inspectors should be more careful in reviewing the PNV to identify the susceptible points and then define the extent of the mixed point circuit. We follow what API has told us, and then we use this to review our process. Upon review, we can see that the RPS, the quenching guys, yes, we have a 4-inch hydrogen quenching piping. It has the temperature inlet is about 360 to 400 degrees Celsius. And at the quenching point, the temperature is around 60 to 70 degrees centigrade. And with more than 300 degrees in the thermal difference, it will lead to thermal fatigue according to API. And the actual picture is as shown below. We also have to look whether this kind of risk is high or low. Upon inspection, and then we use API 574, it says that as long as there is more than 300 degrees difference in temperature, there will be it is a high-risk point for fatigue. And earlier, our example has actually exceeded 300 degrees. So this is a high-risk point. And the gas involved is hydrogen, and we followed API 570, and we classify this as a class 1. And therefore, we carry out a very comprehensive inspection to see whether there will be thermal fatigue at the mix point. We make use of a very efficient inspection technology. And after inspection, we saw some cracks inside. Once we opened the valve, you can see on the right-hand side corner, there were several cracks. And therefore, we can see that this is actually thermal fatigue as indicated by API 574. And this thermal fatigue will lead to possible leakage of high-pressure gas. Of course, once we have this kind of leak, we need to prevent, we need to mitigate. And these cracks were found during inspections, and then we installed a new gauge. And it is very difficult to replace and to repair. So we make use of API 579, which specifies the maintenance process. We want to know whether the cracks will actually lead to explosion. After our inspections and analysis, we found that the cracks are still workable. It are still within tolerant limits. But going forward, we need to be able to avoid mixed point limits. And again, we follow API and install a thermal sleeve in order to prevent thermal fatigue. So I showed you this example to show that many companies may not have material experts. They may not have experts on corrosion. However, if they are able to just read carefully the best engineering practices laid out in API, they will be able to solve many problems. They will be able to carry out inspections and carry out inspections at the proper points, at the proper frequency. All of these are actually specified within API. My second example is corrosion. This is something that's very common to many industry sectors because we have a change in temperature outside and inside the valve, and there's a liquid flowing inside, and this will lead to corrosion. Whether this is for steel industries, for the chemical industries, or for the petrochemical industries. It is very clear in API that the temperature range is from minus 12 degrees centigrade to 175 degrees centigrade. And it says that the corrosion will be localized to wherever the material has been kept wet by wet insulation. Therefore, here we are very clear on the different points where we should inspect. This is a very good example. This is the propylene rectification tower. This tower is about 60 meters high, and it has been in operation for 32 years. If we use API 570, we can see that the carbon steel temperature is minus 12 to 175 degrees centigrade. Therefore, we can see that it is a potential CUI. There are potential CUI issues based on API statements. Next thing that we need to do is to identify whether the risks are high risk or low risk. And then we again make use of ENAA of Japan to carry out analysis. I will not bypass the analysis steps, but the results of our analysis shows that there's a according to API class 1 or class 2, it's a class 1. In other words, if we look at the final analysis, it's a very high risk. And then with this very high risk, we look at API 5A1, which is risk assessment. It tells us to use inspection effectiveness category, use highly effective efficiency. And because we know that it is high risk and we need to use high effective inspection, and based on 581, there are two ways of inspection. First is destructive, or we can use RT plug UT. Therefore, we have carried out our inspection. This is a very huge task because if we did not actually carry out this inspection, then it would be very difficult for us to have 100% confidence in the safety of our equipment going forward. This is the inspection results. It was found that the pipeline has been severely corroded. In other words, there is risk for explosion, and therefore we replace the pipe. And then also look at the surrounding support ring, and near the platform support steel, there are also obvious CUI. The depth of corrosion has exceeded the corrosion allowance, and we just conduct a fitness for service assessment, FFS. After assessment, if we found out that if we did not carry out any repair, there might be a risk of collapse during an earthquake. That's why we carried out different repair and fix. So afterwards, everything was back in order. In this case, we actually make use of the RAGAGEP. We made use of API 570, API 581, and ENAA in Japan. So we carried out inspections, and we actually sorted out all of the defects that we hadn't found over the past 30 years. And because of this, we was able to minimize potential loss going forward. And finally, I'll come to my conclusion. If we look at our past experiences of fires and explosions, mostly were caused by the inability to make use of good engineering practices. It is very important to make use of good engineering practice to look at our pipelines or to define the level of risk and make use of the recommendations from this engineering practice to carry out the necessary measures to correct them. I believe that by doing so, by doing this, by using the good engineering practices, we will be able to lower risk and also to minimize leakage of hazardous gases, and it will also help increase the safety of our factories. Thank you.
We would like to thank Dr. Su Junji. So when it comes to PMS, we have just learned a great deal from Dr. Su. So there are 6 aspects to mechanical integrity. And so inspection, testing are all very important elements of mechanical integrity. RAGAGEP refers to good engineering practice. And the practices derive from international norms, government regulations, and the real-life experience on production site. So I think with good engineering practice, we have a very good foundation to build our process safety management system. So Dr. Su also shared 2 case studies with us, including inspection of pipeline as well as CY inspection. So once again, we would like to thank Dr. Su for a very informative presentation. And now, we would like to move on to the next topic. So the third presentation will be made by Mr. Xiao Li. His topic is CWSAS, meaning Chemical Warehouse Safety Assessment System.
The director of the BEST, Greater China, and the chair of the AICM, the Responsible Care Committees. Following the Enterprise Work Safety Committee's members of the Ministries of Emergency Management, National Safety Science and Engineering Institute. And there's duties of Director Generals of the CFCIF Responsible Care Committee. He is also of the National Register Safety Engineer with more than 20 years experience in EHS and operation in the chemical industry.
Without further ado, let us welcome Dr. Xiao Li to begin his presentation. Thank you. Well, we seem to have some problem with the video link with Dr. Xiao. So we just talk about mechanical integrity, which plays a very important role in PMS. So Dr. Su has given us a very informative presentation. So what I would like to emphasize is that we need to adopt a systemic approach to RAGAGEP. In other words, we can begin with real-life case studies, and then we will be able to evaluate whether or not our engineering practices will be suitable for our own operations. So we shouldn't just resort to reading API 570, API 580, API 579. So without further ado, I would like to turn it over to Dr. Xiao so that he can begin his presentation. Thank you. So ladies and gentlemen, again, we haven't really ironed out all the kinks yet, so we still couldn't get a good communication line with Dr. Xiao Li. So again, I would like to spend on what I was talking about with regard to the presentation by Dr. Su. As I was saying, with RAGAGEP, that needs to be connected with real-life experience. Because if we read API standards, those are just written document. But when we actually do the testing or inspection, what would be the best or most suitable method? I think we really need to tap into real-life experience. In other words, we need to refer to real-life experiences so that we can identify the best approach when we want to carry out tests or inspections. We need to know what those engineering practices are all about and how can we best manage the risks associated with our operations. Obviously, when a factory is built, in the beginning, we didn't really incorporate RAGAGEP into the process. So once a factory is completed, we need to be clear about exactly what kind of risk factors we need to take it into account and how can we identify those risks. And once identification is made, we should utilize our RAGAGEP in order to effectively manage those risk factors. So I think in a nutshell, that was what Dr. Su wanted to emphasize with his presentation. In other words, we need to know how we can build an effective PMS system in order to ensure mechanical integrity. We still couldn't hear from Dr. Xiao. So now I would like to...
Yes, I'd like to continue my talk with PSPI. PSPI is something that is very important. Mr. Bernard Leong has made a very clear explanation on this. Dr. Su also mentioned the RAGAGEP concept. PSPI should be part of the risk assessment. We need to use PSPI to identify the different activities to be carried out. This can help us know what are the controls that need to be undertaken. During this process, we will carry out PSAMI. And then from AMI, there's one very specific control point where we look at what are the ways by which I can increase mechanical integrity. I have some PSPI indicators. How do I incorporate the indicators into MI? By doing so, we will be able to fully realize the spirit of PSPI. I think this is something that is very noteworthy about PSPI. However, we talk about mechanical integrity. There are also other product safety management areas. For instance, participation by the employees, or risk assessment. There are so many activities to be undertaken under PSM. How do we integrate all of these activities to let them become a part of the management process within a factory? This is something that is very important. We can make use of this to formulate our PSPI indicators. This is normally what we do in our PSM process. We want to look from a system perspective to take a more systematic overview of everything. We talk about risks. There are so many risks, so many activities. How do we actually carry out each and every one of these activities? Then we go back to PSM. In addition to risk assessment, there are also other things that we need to do as a follow-up. And we just stop for now, and then I will hand over the floor to Mr. Xiao. I hope that right now Mr. Xiao will be ready.
I would like to apologize. There seems to be some problem preventing me from entering your system. However, we are able to hear you. Well, because I'm speaking on my mobile phone.
So first, let me quickly introduce this AICM. So I present RCC Responsible Care and Chair for AICM. AICM is really established in 1988, and represents nearly 70 major multinational companies in chemical industry of China. So those companies covers from the manufacturing and the transportation, distribution, and the disposal, all whole value chains. For AICM, we have a clear commitment. First is really promote responsible care in China, and also other global recognized chemical management principle among all stakeholders. The second one, we also would like to advocate cost-effective and science and risk-based policies to policymakers. We know quite well in China, so how to support the whole chemical industry to make a science-based policy of this part. Another part also we think is important for AICM as one and the multinational and the company and the member companies of the association, how to build up the contribution role for the whole chemical industry. Next slide, please. This is our AICM member companies. You can say almost all the major multinational companies are member companies. I will not name name one by one. So next one, please. So as the AICM association, so we be the rainy bridge to internally first in international part. We do this kind of collection with ICCA, RCLG, and CEFIC, also with APSPC, all those kind of really international associations. Meanwhile, also for local China part, so be then the local government, technical and associations, academy and NGOs, all those kind of really associations, we also connect to each other. We think AICM, so we be then really and afraid to extend our partnership with all stakeholders. Then come to my topic regarding our chemical warehouse safety assessment system. Next one, please. Before I introduce our chemical warehouse safety assessment system, I would like to share with the CWSAS, Chemical Road Safety Assessment System. Actually, started from 2008, AICM started to work together with an MOT, Ministry of Transportation. Then we do our so-called Chemical Road Safety Assessment System. Because the background is quite clear. In that time, we think this safety situation in China for this road transportation for chemicals is not so good. We want to do something with all the member companies, also for the whole chemical industry. You see already 14 years passed away. I think it's a long journey, but with all the effort with the AICM member companies, I think already have 22 AICM member companies start to use this system. This system can support all the chemical companies conduct this so-called really third-party assessment. Meanwhile, now already extend this kind of really system to other local companies. For example, for a local, very big one, and chem and chemical companies also start to use this kind of system. Now already we start to use almost every year, 300 assessments have been done. So every year you can see more than 70 assessments, which means we are qualified more than 70 so-called logistic service provider for transportation part. Based on in the past 14 years, we received quite many and positive from member companies, also from government, also from whole industry and stakeholders. I think we have very comprehensive questionnaire. So we include this CEFIC and good practice also with the local legal requirement. So can support the local improvement for the chemical and the transportation part. Then bring this kind of good practice. Then we say maybe we can do something more, extend to warehouse management. Next one, please. Then we say we need to have one, and another one is CWSAS. This is one so-called Chemical Warehouse Safety Assessment System. The background is quite clear because you know also recently, so many accidents happened, either in China, also globally. So we think somehow for them how to properly store our chemicals, how to properly manage this chemical warehouse. It's really important for us. Then how we can support the sustainable warehouse operations in the chemical industry in China. Recently, it's really, and the chemical industry in China is booming. So many investment. It's really big demand for chemical warehouse. Then also for member companies, we have some challenge. It's difficult to find really and qualified enough hazardous chemical warehouse. Then we also set up the similar system. This can support our member companies to really and have one and assessment to easy to find a qualified and warehouse. Also can save some really and cost or some effort, because before time, if we and one company, the one find a qualified and so-called and warehouse, we need some people to do the assessment individually. It's a lot of timing for everyone. Meanwhile, so by doing this and the system, we also want to further improve the whole chemical storage industry EHS management competence. Because while this kind of system, we also can do a lot of training, also introduction to all the participants, all the small players especially. This also is really bringing more value to all the member companies. Then its logic is really quite clear for the purpose. Then we do the purpose first do the survey, develop the questionnaire. Then we do the trial, do some preparation. Then we go live for the system. I will spend some time to introduce the CWSAS in detail. Next one, please. This is this basic setup for our CWSAS. You can see we just set one independent third-party platform. Then if any warehouse they need assessment, they will send a request to this platform. Then we will assign the one qualified assessor to conduct this assessment. And this system have so-called standardized assessment questionnaire. Then this the questionnaire covered also local legal requirement, also with the specific requirement, could plug together. This really also combine all the leads from all the member companies. I think also for multinational companies, quite a similar thing. After that one, then you can do this system also is really for qualified assessor. We also regular do some evaluation. Qualified assessor can do this assessment. If he's not qualified, will be eliminate this assessor in the system. Also, another thing, this one is really based on all the fact-based, based on the questionnaire. We have no grading assessment. We are not disqualify any warehouse. We just put all the facts based on the questionnaire. What's the fact observed during the audit? It can be support this member company further based on all the findings, all the assessment to conduct further assessment, whether meet the company requirement or not. This kind of overall structure. Next one, please. Actually, for this CWSAS system to set up is not so easy. We started from end of 2020. First, a lot of discussion. We set up the technical community, also have meeting planning. So we also do some preparation and collect all the input. What's the local legal requirement, also CEFIC and the questionnaire. Then we discuss all the kind of procedure, assessment, then prepare this questionnaire. Also, we report this project to RCLG, ask for support. We also, with this kind of support from RCLG, we conduct several rounds, so-called really capacity building, to discuss with all the stakeholders to identify the way how to make this questionnaire, the system. Luckily, we just really announced this go live in August 2022. You can see the picture before. And during our AICM and RCC meeting, we will launch this system go live. Now we already conduct assessor and training. Then we targeted to formally go live for this CWSAS system to conduct those assessment in the beginning of 2023. This is the journey. So this is the only start point. Of course, we will continue to stay and start to assess this and the warehouse, also do some learning in the future. Next one, please. This one I would like to share with you for this, and the picture can say for this and the team. The many come from all the member companies, all experts. They conduct a very intensive monthly technical committee meeting, also with AICM support, capacity building workshops. They prepared all the questionnaire and the pre-assessment document, the guidance. You can say this kind of document, the guidance and questionnaire is really based on both scientific questionnaire and plus local regulations. After that, all the software are really formulated, then can be used for all the manufacturer, also warehouse and assessors. Next one, please. Let's go deeper regarding what the questionnaire and content. First one, you can see the core questionnaire part is chapter 1 to 5. This is really applies to all warehouse. The mainly cover, you can see 11 elements. The overall management system, risk management, and the human resource, and so on. All the kind of the basic and management system part. So if this kind of warehouse, they want to meet all the requirements, then you set up very, very comprehensive so-called management system to manage everything. Besides all the questions for chapter 1 to 5, we also have specific some requirements. Next one, please. We also have specific questionnaires for chapter 6 to 14. This one is really depends on the different requirements. For example, for different warehouse, they have different assessment scope. They have 10, you can say 10 elements. They're quite similar, but it's different content inside. This you can say including some, for example, on the fire control management, storage, operations, and code of behavior conduct, warehousing, security, on-site operating procedures, and food, and contact, those kind of things. Based on this general requirement of a questionnaire, also for the specific questionnaires, we can really meet the diverse and demand for different type of warehouse. For general warehouse, also for hazardous warehouse. That's very quick introduction about this CWSAS. Next one, please. This is my last slide. I would like to say this and the CWSAS 15, I think it's really a beautiful thing. It's really can do some tailor-made warehouse safety and readiness assessment because they have so broad and the content inside. Also, you can do based on your needs different. Another thing is important is really for business networking or the benchmarking because so many member companies here. So we also want to know the difference in different regions. There's the warehouse management situations. It can easily to provide transparency for every member companies to say the warehouse and the safety management situations. Another part that's the most important thing is really also ensure there's a compliance of regulatory and the guidance all inside already. So when you conduct those assessments, after that you can sign you on the find you and qualified warehouse and the service provider. Then you can sign your contract, can fully meet your company also local legal requirement. So I say those kind of really and the system definitely will benefit for whole chemical industry in China, especially in the coming days. We think and more and really and the demand in China. So also is how to improve this warehouse and performance. That's my sharing. Thank you. Sorry again for my technical issues.
Thank you very much, Mr. Xiao. Yes, through the presentation of Mr. Xiao, we have understood some of the operations of AICM, as well as CWSAS, its questionnaire and also risk management. I would like to thank the information provided by Mr. Xiao. Next, we will proceed to our panel discussion. I would like to invite Dr. Su. First, I would like to also greet our friends online. We had some technical difficulties early on, and we are glad that we were able to fix the problem very quickly. If you have any questions, I'm referring to our friends online, feel free to ask them using the chat box. I would like to right now invite our distinguished speakers to share with us some of their views on safety. I would like to ask Mr. Bernard, are you online? Yes, very good. I will just proceed according to the order in our agenda. Yes, I would like to invite Mr. Bernard to talk to us about the PSPI indicator. I think this is a very good practice. It's a very good approach because we're using an indicator to assess the results of our safety system. My question is, for new companies or emerging companies at the beginning, when they're just starting out with PSPI, they may not be very clear as to what activities they need to carry out. I'd just like to ask you to share with us with some of your experience in your company, PCS. I'd like to know that, when did you actually start to introduce PSPI into your company? In other words, how long have you been in operations before you start actually implementing PSPI? Thank you.
I think there's two parts to this to the question. The first one is for new companies, what should be the PSPI, and second part is that for my company, when did we start this PSPI program? So let me answer the second part first. Now, first safety or even PSM was something which was not really talked about in early years. It only came about after the Bhopal incident in India, and then it was like sort of quietened down for a while. And what brought up the prominence again was the BP incident in Texas City. So I think that was the second wake-up call where industries started to look at safety in with more awareness, and we also measures on how to prevent such incidents. So also on that also we started our process journey in about year 2000 or so, and from then on we have been involved in many platforms with the American CCPS, with the HCUK, for basically in a way to seek guidance, also using their guidebooks about how we can further enhance, further develop our PSM and also the PSPI. Now, on the question about new companies, there are quite a lot of nowadays, not talking about like 20 years ago, but currently now, there are quite a number of guides, papers, or even books available about the PSPI, how to select, what some of the ones that the company should look at for. And I think I would say that each company, there is no like, how would I say, one size fits all kind of a solution, because each company needs to look at their risk appetite, what's the risk tolerance in terms of, for example, consequences, whether there are nearby facilities, where they're located, any neighboring companies and all that. So the risk tolerance and risk appetite is a bit different company to company. And also in terms of the resources that are set up, about how, to how much they can actually benefit from this, and how much they need to actually also have some kind of, I would say, like start small. Like what we started small, we only like 6 indicators, then we slowly develop and look at further focus about how to improve. So start small with just a few indicators and see whether it works for you, as well as also how these indicators help you to sustain your facility performance. I hope that more or less answers the questions. If not, yeah, I'm more than pleased to explain more.
Thank you very much, Mr. Leong. I would like to thank you to provide for you for providing us with such informative content. As you have said, each company should look at its own capabilities, look at its resources, and then determine what kind of activities should they undertake. I think this is something that each company should decide for themselves. Mr. Leong also mentioned that in PCS or other international companies are all have information related to a PSPI for everyone to look up. And then when you take hold of this information, you can actually look for pieces of information that actually suits your company. As Mr. Leong mentioned earlier or during his talk, in the beginning, we don't have to do everything. So we start from the core, and then we gradually move outwards. During this process of doing, we also learn, and then we will be able to gradually set up a very good safety mechanism. Thank you, Mr. Leong. If we still have time, then I will go back to you to ask more questions. Next, I would like to ask Dr. Su. Your presentation is very informative. You talk about API 571, 571, and 574. All of these are actually good engineering practices. However, my question is, how many people can actually incorporate API 570, 571, or 580 to incorporate all of this into one system? Because this is something that is very difficult. Therefore, my question is, how do we make use of RAGAGEP, right, to carry out mechanical integrity inspection? Of course, during this process, there needs to be people who are experts in API or in whatever engineering practices that is relevant. How do we familiarize ourselves with this kind of regulations? Of course, we cannot compare with Dr. Su. Dr. Su, you have many years of experience, but for those less experienced engineers or companies, how will they be able to gradually incorporate this good engineering practices into actually what they're doing in their company? I think the international standards are actually there for many years, and then it's very fortunate that we, at our company, we have this capability. But in the early years, we were unable to fully understand. We were unable to digest and incorporate API into our company's regulations, guidelines. When we talk about, for instance, corrosion, we often talk about corrosion within our company. But when we ask our inspectors what is corrosion, what corrosions are we actually looking for, many times they were not able to answer. However, if we look at, for instance, API 577, API 653, there are very specific corrosions, very specific equipment. Therefore, my suggestion is, within a company, I think there needs to be training on international standards and regulations. And after the training, or the training should include not only the inspectors, but also the maintenance people and the design people. And after training, then we can gradually convert the API standards or API guidelines into the SOP of a very specific company. And during the process, we need to link process engineers, designs, process, and everything. I have a materials background. We talk about mixed points. Before actually looking into API, I didn't know too much about mixed point, and many of our inspectors never heard of this term. Therefore, it is important to look into the API guidelines and then fully understand them, and also translate this knowledge to the people within the company. Another example I mentioned is the washing using water. Washing is very easy. However, those in the manufacturing processes, they don't know this. The inspectors may know this, but they don't know anything about manufacturing processes. Therefore, what I'm trying to say is that we need to educate our people from different departments, people from different processes. By doing so, everybody will be on the same page, and then we will be able to identify defects quicker. In short, we need to make use of training, and training is not only directed to inspectors, but to all those involved. Thank you very much. Thank you, Dr. Su. And I'd just like to briefly summarize. In a manufacturing company, first we need to develop these professionals, and then they need to be knowledgeable about international guidelines, not only API. And then after they have this basic knowledge, then we can look at the life cycle of our equipment. And then we look at design, maybe whether it be a basic design or detailed design. Then we have assembly, inspection, pilot run, and also final operations. In the different phases, there will be different questions or different problems. And facing these problems, you need to be able to make use of the knowledge you acquired through your basic training and put them into use. And this knowledge refers to a knowledge of the API and other international guidelines. By doing so, you will be able to integrate this knowledge of the international guidelines into your daily task or your SOP. I think this is what Dr. Su wants to tell us. Thank you very much.
Okay, now our third speaker, Mr. Xiao, is still online. We would like to apologize to you because there were some technical issues. But we still would like to thank you very much for participating in our conference. Well, in your presentation, you touch upon two major issues. First of all, the safety with regard to road system and the safety regarding the warehousing system. Because we all came from a technical background. So typically, we will focus our attention on factory operations. However, as you have mentioned in your presentation, there have been explosions occurring in the harbor in Tianjin and at Beirut harbor. This means that typically we have ignored warehousing system for a long, long time. Thank you very much for bringing our attention to the safety requirement for warehousing system. So I have a question for you. Obviously, in terms of designing a warehouse, for example, structural strands, firefighting design, they would be fixed design. Once the warehouse is built, it's already in place. But we could store different chemical substances at the warehouse. So my question to you is that in terms of dangerous goods, before they are stored inside a warehouse, how can we effectively classify dangerous goods into different categories so that they will be stored in different parts of the warehouse? I think that's very important if we want to prevent fire or explosions. I'm sure you have carried out large-scale questionnaire survey, and there are probably laws and regulations mandated by local government. So my question to you is, how can we effectively classify dangerous goods into different categories? For example, in terms of the size of the good, or where in the warehouse they should be stored in. So is there any updated information you can share with us? Thank you.
好的，这些主持人的
Thank you very much for your question. Well, indeed, exactly as you have mentioned, a lot of attention now is being focused on how to build a safe warehousing system. Well, there have been a lot of laws and regulations by local government throughout China. Dr. Xiao, for some reason, there is very strong interference to our link. So again, we need to put you on hold because there has been very strong interference with the signals that we are receiving from you. So we need some time to get your line ready before we will invite you to respond to my questions again. Well, we have a question online, which is addressed to Dr. Su. In terms of mechanical integrity, we would like to know when we implement PSM, whether or not the mechanical integrity can serve as an effective indicator for PSM. That's question number one. And number two, do you have any recommendations in terms of how we can assist SMEs to come up with better and more effective PSM? So when we talk about PSM, incident investigation is actually a key part of PSM because once we have investigate an incident, then there will be lessons learned. So this is what we consider to be lagging indicator. And once we have a lesson learned after we complete investigation of an incident, then obviously we can accumulate some experience in order to prevent the same thing from happening again. And ESB report produced in the United States is a very good case in point because in their report, they will clearly identify the vulnerability or the weak point in the entire management system. So if we want to prevent incidents from happening again, obviously what I have just mentioned is just a lagging indicator. And obviously we want to be able to prevent things from happening in the first place. So we need to begin from the design phase. And that is, if we can study all the international best practices, then we will be able to turn lagging indicator into leading indicator. And we will be able to be more preventive in our approach. PSPI, as introduced by Bernard, came to mind. PSPI, as mentioned by Bernard, there are leading indicators and lagging indicators. And basically, we need to begin with evaluating and assessing our own system first. So even for lagging indicators, they do serve a purpose. But exactly as mentioned by Bernard, we also need to come up with some leading indicators. In other words, once we are done inspecting or analyzing incidents that have already occurred, we need to be able to come up with some prevention measures. Because once we investigate a past incident, we are able to identify the root cause for those incidents. And so we can then tap into our RAGAGEP, and we can try to identify some preventive measures from good engineering practices. And if we can incorporate those practices into our PSM, then we will be able to be more effective in preventing newer incidents from happening. So now I would like to go back to Mr. Xiao. Once again, my apologies to you in terms of warehouse safety evaluation system. Could you finish your comment? Thank you.
Thank you very much. I'm sorry for the technical difficulties. We talk about warehousing. Actually, from a legal perspective, China already has a very clear stipulations. For instance, in 1995 and also 2002, there is a regulations concerning chemical products. And normally, a warehouse during the design phase, there will be stipulations stating that what kind of chemicals can be stored in that warehouse, how much chemicals and in what location, and what is the danger level of the chemicals. There will also be a compatibility testings. These are all stipulated. However, in actual practice, there might be some businesses or some organizations, because of their lack of ability, lack of capability, or maybe of other concerns, there might be some discrepancies. I believe that there are many ways to overcome this. The bigger companies and businesses, because they will have internal guidelines saying that, okay, how much chemicals can be stored where, at what location. And based on this quantity and the type of chemicals, there will be measures put in place so that if in the event of a safety issues, then for instance in Shanghai, there will be more mandatory requirements. In other words, for every chemical, as long as it is in a warehouse, there needs to be a very clear guideline saying that how much can be placed inside the warehouse at what location. And this information will also be sent to the government for recordation. And there's also monitoring procedures. For instance, everything will be monitored to make sure that everything is in compliance with regulations. Once all of these steps are taken, then there is a high possibility that all of the incidents can be prevented. However, I have to admit that not all warehouses are like this, because some may or may not be able to do so, especially those smaller warehouses. They may or may not have the ability to do so. Therefore, it is very important to provide training to all warehouse operators. We also talk about regulations. I think this is also a very good question. However, recently there have been it is very fluid. There are so many requirements on chemicals, and it's also very difficult to actually cover all of the chemicals. For instance, in 2013, about 9 years ago, and also in recent years, there have also been proposals to amend the current legislations. We currently do not have the final version yet. What I'm trying to say is that in China, there is a change that's ongoing, and we want to be able to improve the current situation. We want to help all of the operators to fulfill their responsibilities. For instance, the competent authorities, the businesses, they will all know their responsibilities. Number two is to classify the chemicals and to manage them accordingly. Thank you. A very informative talk, and I hope that in the future we will have opportunities to understand more about these classifications. I feel that warehousing is, of course, important, but the classification of the things that go into the warehouse is also very important. Once we have this information, we will know what are the things that we can put into the warehouse and where to put them. Another thing that is very important is personnel training. The warehousing people need to know how to put the items into the warehouse and how to maybe store them. And finally, we are close to the end of our conference. Everybody is very tired. We still have some time. Finally, just last call, Mr. Leong, do you still have any comments to add? Mr. Leong, do you have any additional comments?
As on a final note, I just want to say that basically to develop this PSPI program is actually to strengthen and also to help companies to look at their PSM, their facility management, the whole system, and also look at the backdrop of against incidents, as well as also practices. So like maintenance practices, mechanical integrity is all part of the PSM. Heads up, MOC, message of change. All these can be incorporated as indicator. So indicator complements PSM, and it also goes a long way towards improvement in performance. Thank you.
Thank you very much. Anything more to add by way of conclusion? Thank you very much. On behalf of AICM, I'd just like to mention that logistics and warehousing safety will need participation of all stakeholders, including the competent authority, the businesses, and also other relevant people. This is a very long journey, and I hope that we can continue on our journey and to increase awareness, not only in China, but also in other countries, so that the entire warehousing industry can improve their safety management. Thank you. And finally, Dr. Su. Okay, no more. And I would like to thank Mr. Leong, Mr. Xiao. I would like to thank you, and thank you, Dr. Su. Safety is actually a very long journey. It covers a very broad scope. However, if we are inadequate in our safety measures, then it's going to be very difficult for our chemical industry to move forward. And finally, this ends our conference today. I wish all of you good health. Thank you.